What's up, everybody? Welcome back to another live stream from the Scalar Learning channel. And today we are continuing with more SAT math as per usual, as we got the August SAT right around the corner on August 28th. So we're going to be doing a lot of stuff, for the next few weeks leading up to it. And we got some cool stuff that we're going to be releasing soon, which I'm going to keep on the DL for now until we get closer to a target date and release time. But something that a lot of people have been asking for. So just doing a quick little audio check, making sure my audio is running smoothly. And then once I know for sure. Yep, it's good. All right, so here we go, guys. And we're doing a time mini section. If you guys are new to these, hey, Nubis, hey, let's go. What's up, Nubis? Yeah, so we're doing more of these mini sections. If you haven't seen these yet, I love them. The mini sections are a really good practice. I do them with a lot of my students, and they're a nice mixed review. This is going to be a timed one for 15 minutes, and it's calculator. So I'm going to load up a calculator here. Oops. Let's see. All right, we got the calculator in the mix. And make sure we're in the right Zoom. And what's up, Quang? Nid Rocks, what's up? All right, we got to jump right in because I got a tutoring session in about 19 minutes. Here we go. We're going to start in 3, 2, 1. What's up, Rabab? Let's do it. A caterer is determining how many forks you will need to. Let me get the drawing thing up. A caterer is determining how many forks you will need to buy for our upcoming event. Each adult. Oh my, what's happening? Hold on. I didn't change this. Come on. No transparency. Oh my gosh. It's glitching. This is bad. I literally just had to order a new Wacom tablet because mine is glitching like crazy. But let's see if it hopefully works now. Come on, buddy. Yes. Okay. So we need 5. Oh, it's doing it again. Oh my God. Hold on. Hold on. Let me unplug it and plug it back in. All right. Come on, buddy. Come on, buddy. No. All right. Let's see. Let's hope. Okay. So she needs 5 forks and every child needs 2 forks. So 5 forks and 2 forks. So the event will host 764 adults and children in all. And they ordered 2992. So it's a system of equations. So we need... 764. So we should say, I should do 5 times adults plus 5 adults plus 2C equals that. And then we also know A plus C equals 764. There's a system of equations. And we're trying to solve for C. Let's multiply the top by -5, -5, and -5. So it's a -5A minus 5C equals, it's glitching again. Come on, buddy. This is really, sorry. Okay, and then equals, can I do it in my head? 3,500, 3820, 3820, and it's negative, right? So then, man, it's literally been working all day, and now it's doing this. Hold on. Let's see. All right, come on, buddy. So then now let's add it together. And what was that? 2992. All right, I'm going to use the calculator. 3820 minus 2992. And I know it should be the other way, but okay, so that's -820. -828. The A's cancel out equals -3C divided by 3. And we get 276 children. 276 children. Oh, it said adults and children, but this is the only one that's right. 276 children. Done. Okay, next. A scientist wants to collect data about the effects of gravity on the growth of soybeans. Says that about soybeans grow better in a zero gravity setting. She separates soybeans into 2 groups. The first group is grown in typical soybean conditions. The second group is grown in zero gravity. Which of the following best? Okay, this is a controlled experiment because you have a control group where it's grown normally, and you have the one that you're testing the zero gravity on. Boom, done. Leah's car travels at an average of 30 miles gallon per gas. 30 miles per gallon. If she spends $20.70 on gas for 172.5 miles, what is the approximate cost in gas for dollars? Okay, so we do 20.7. So actually, hold on. Let me think about this. We have, what was the approximate cost of dollars per gallon? So let me think. This is a rates problem. So we have dollars per gallon, and she charges 30. So she goes, hold on, 30 miles. Or how about this? She goes 1 gallon in 30 miles, and she does 172.5 miles. So if I multiply these two, I'll do a little cancellation. I'll figure out how many gallons is used, which is 172.5 divided by 30. So that's the amount of gallons, which is 5.75. And then we want the cost dollars per gallon. So whenever I see that word per, I think about it as a division sign. So it's the amount of dollars, $20.70 divided by per gallon divided by 5.75, 20.7 divided by 5.75, which is $3.60 per gallon. Okay, that feels pretty good to me. Let's keep rolling. Number 4, the strength of the magnetic field measured in Teslas. 1 Tesla is equal to 1 Weber per square meter. Okay, they underlined that. Okay. Divya is building a circuit for a physics class. Point P on one of her wires has a magnetic field. Wait, hold on. Point P on one of her wires has a magnetic field strength of 6 times 10 to the 6th. Okay. Oh, sorry. There we go. Webers per square megameter, where 1 megameter is equal to 10 to the 6th meters. So 1 megameter. Square megameter. So look. So I have to replace the megameter, because it's megameters squared, and 10 to the 6th meters is a megameter. So is this value squared? What is the magnetic field? So this is what it would be. And then we just have to convert it, because this would be the megameters squared now. We just basically did that conversion. So now it's like 6 times 10 to the 6th over, really that becomes 10 to the 12th. So now we use our exponent rule. So it's subtract when it's division. So it should be 10 to the negative 6th. 6 times 10 to the negative 6. So I believe I did that correctly. It's an interesting problem. Okay, number 5. Which of the following graphs represents this? Got it. Point slope. Beautiful. So we need a negative slope, a slope of negative 3 over 2. And the point 8, comma, negative 6 is a point slope. Opposite that, opposite. 8, comma, negative 6 should be on here. 8, negative 6, yes. And then is it negative 3 over 2? Down 3 over 2. It's A. But should I see the other ones? Yeah, this one doesn't have 8, negative 6. This one doesn't have 8, negative 6. Oh, wow. None of them do. So it's got to be this. I guess it's just testing point slope. Just make sure I didn't make any mistakes. Yeah. All right. Next, 6. The ability of geckos to climb on shears is attributed to van der Waals force between these surfaces and microscopically. Okay. The van der Waals force, this, measured in micronewtons, between a sphere representing a spatula. What? Okay, hold on. The van der Waals force between a sphere of radius r, so that's the radius, and a plane, the wall, is shown above. Oh my goodness, and a plane. So it's a sphere and a plane. Okay. How am I doing on time? 8 minutes. Oh my God. Okay. So is that representing r microns, nanometers? Is this, and where r is, the little r is the nanometers. That's I'll just say distance from wall, distance of these two. So this is r, little r. A is some constant. If the distance r, okay, now I got it. If the distance r decreases by 50%, so if it was, let's say 10, now it would be 5. And so 10 squared would be 100, and now instead of 100, we'd have 25 on the bottom. Which of the following describes the effects on the van der Waals forces? So since we would be dividing by 25 instead of 100, it's like multiplying by 4. So it would quadruple, and there's our answer. Next, 7. The table at the left shows low-budget airline companies' percentage share of all low-cost seats in Philippines. Low-budget airline share. Hold on, let me understand the graph. So in 2004, low-budget airlines had 28%, then 34%, 40%, and so it keeps growing, their percentage. Which of the following statement compared to other airlines? Which of the following statements best describes the growth of low-budget airline percentage share? The growth is approximately linear. Let's see. It's going up by 6, then it's going up by 9, then it's going up by 7, 6 is 13, then it's going up by 18, right? 18. No, sorry. 22. Does not look linear. Goodbye. The growth is approximately linear. No, it doesn't look linear. The growth is approximately the percent of decreased growth an average rate of 1.3. The growth is approximately exponential the percentage. Grows at an average rate. Oh, it's either 2 years or 1 year. So let's see. So 28 times 1.3 is 36.4. 36.4 times 1.3 is... Yeah, so I think it's this one. It grows at 1.3 every 2 years because they're showing in 2-year gaps. So if I keep multiplying by 1.3, etc. Let me just do this one in my head. 30%, 56, 15, 18. Yeah, 18. I mean, it's close enough. Just to double check, 1.3 times 56. Yeah, it's close enough. So every 2 years. Okay, this one. Hold on. Come on. 5 minutes left and 3 pounds to go. Okay, Dante and his friends ordered pizza for a birthday party. They asked all the guests at the party whether they wanted sauce or no sauce and whether they wanted cheese or no cheese. So Dante found that 1/5 of the people who wanted cheese, so that's 20, so 4, did not. 1/5 of the people who wanted cheese did not want sauce. 1/5 of the people who wanted cheese did not want sauce. So that's 4, and that's 16. What fraction of the people who wanted sauce, now I can fill this in. What fraction of the people who wanted sauce also wanted cheese? 16 out of 18, which is 8 out of 9. Boom, done. Okay. Next. 4 minutes left. We're really cutting it close. Maria burns about 600 calories per hour jogging and about 450 calories biking. If Maria spends X hours per day biking and 4/5 as much time jogging, which of the following functions best models the amount of calories that Maria burns in 1 day from jogging and biking? So it'd be 4/5 X times 600 plus 450x, and 4/5 of 600 divided by 5 is 120. I'm sorry, yeah, divided by 5 is 120 times 4 is 480. 480x plus 450x, which would give 930x. Boom, done. All right, last question, 10. It's 3 minutes to go. Not bad. Wang Z measured the brightness of a glow stick. The equation below models the wait a minute. Oh, yeah. That was I thought it was isolating quantities, but it's not. The brightness in lumens H hours after activating the glow stick. Okay. H hours. It's pretty straightforward. Which equation best highlights the number of hours it would take for Wang Zhu's glow stick to lose 90% of the brightness, meaning only retain 10%. All right. Well, obviously at 0 hours, it's at a 4. So the question is how many hours is it going to take to get it down to 0.4? And the equation should highlight the number. So that number of hours should be here. This doesn't make any sense. 0.73, it just doesn't show the hour. What they want is they want it to be there as a constant. I'm betting it's C, And I bet you it's 7.3 hours. If you plug, and look, here's the 4 times 0.1, which will give you 0.4, like we said. But I bet you we can verify this by plugging into the original equation. So check this out. Here. First, let's do 0.773 to the 7.3. No, sorry. Yeah. To the 7.3. Let me just select this so I don't run out of time in case, as I show you this to you, equals that times 4. Boom, it gets you the 0.4. So you know that shows you the constant. That's the winner. Let's just go for it and see how I did. Okay, we nailed them all. Yeah, that's it. I don't think there was anything. This one was a little iffy because it was just different, but we're good to go. So thank you guys for all joining. If you can do a video when you work on problems, of how you approach them and how you create equations, since it's confusing and hard. Yeah, sure. I mean, these videos, obviously they're faster, but yeah, that's a good idea actually. So something where I'm crafting the equations as I'm reading, like a little bit slower perhaps. And oh, let me say this too, by the way. This is harder than like real SAT questions. Pretty much all of these, not like so hard as the level 4 regular problems, but this is pretty tough. What's up, Sean? MMA fans, I'm so excited for Usman Covington. In a fraction, what is a common denominator? A fraction, a common denominator would be, for example, if you have 2/3 and 1/4, it would be if we can get them both to 12 via multiplication. So I'd multiply this by 3/3, this by 4/4, and we'd get 8/12 and 3/12. Now they have a common denominator, the bottom number. Let's see what else. And by the way, guys, thank you so much for all the likes. I really appreciate it. I know a lot of you guys are liking preemptively even before I start. So that really, really helps the channel and helps everybody in terms of spreading the word and getting more people the help they need. Do more QAS videos. Yeah, I mean, I've done all the ones that are publicly released, but so we're figuring out what to do leading up to the 28th, and we might be redoing a lot of those. We might be redoing the College Board test. We're not sure. We're going to do something really cool and really special for the 2 weeks leading up to it. So we'll take ideas or suggestions or anything you guys have. Okay, I got to roll because I got to jump to a tutoring session and we're done anyways. If you do have questions, leave them in the comment section below. If you did like this video, please click that like button. If you want to see more videos from the Scalar Learning channel, make sure to click subscribe. And check out our YouTube channel, Math Puzzles, as well. Just search Math Puzzles Huzefa, and there's a ton of extra practice problems for you guys that are all related, but also a lot of fun to this whole process. Thank you guys so much for joining, and I'll see you in the next video. Take it easy.